We're going to review our Algebra 1 and Systems of Equations review unit for the final. So what that unit started with was just reminding ourselves how to solve basic equations and inequalities. And the first steps for those are to distribute and combine like terms. So 2x minus 6 minus 5x equals 4 minus 5x. And we're just solve-a-rooing this. I'm sure at this point most of this is review. Switching sides and everything, so x equals 10. Same thing happens with inequalities. The only difference with solving an inequality is that when I multiply or divide by a negative, then I will switch the sign of the inequality. So 2x minus 1 is greater than 3x minus 3. I am going to subtract 3x from both sides. So negative x minus 1 is greater than negative 3. Add 1 to both sides. And then divide by negative 1, which is going to switch my inequality and switch the sign on the other side. Then we looked at compound inequalities, which you may not have seen separately before. But when it's separated by a word, it's not a big deal. We just solve them completely separately. So this first one would be minus 5, divide by 3, or minus 8, divide by negative 4, all right. Now, this is the one that we still were having a little bit of trouble with. So what you want to do is look, if I, at the inside, so I have x plus 3, how would I solve for x there? I would usually minus 3. Well, you do that. It's just that you're doing it on both sets of your inequalities. And you just keep it chunked together. So negative 1 minus 3 is negative 4, is less than x is less than 2. So that was our solving basic equations and inequalities. Then we looked at linear functions and graphs. So slope is change in y over change in x. I still have some people flipping that. Change in y over change in x. I'm being really lazy there with my quotes. All right, so if I want to find slope, and our special slopes are undefined, which is when we have a number over 0, and 0, which is when we have 0 over a number. Remember no and okay? All right, so if I'm finding slope, you want to say in a table, how do I go from negative 4 to negative 2? That would be plus 2. How do I go from 0 to 6? That would be plus 6. So my m would be 6 over 2, which is 3. Okay? The other thing to do is y2 minus y1 over x2 minus x1. From a graph, you want to find points that are going through corners. So these are the two I'm going to choose, and we do rise over run. So up 1, right 2. So a slope of 1/2. And then in an equation, I need to solve for y. So in this case, I would minus the 2x over, and then divide by negative 4. So y equals 1/2 x minus 3. So my m would be 1/2. Okay, the other thing we looked at were intercepts, x and y-intercept. An x-intercept means that y is 0, and a y-intercept means that x is 0. And these are not the same as slope. So my answers are not going to be what I have already written up here. So we're going to go back and say what our x and y-intercepts are. So in the table, an x-intercept is when y is 0. So that's going to be my negative 4, 0 point. Y-intercept is when y is 0. Sorry, y-intercept is when x is 0. They're opposites. Okay. Then on a graph, my y-intercept is where it crosses the y-axis. And x-intercept is where it crosses the x-axis. I almost wrote x-axis, bless. All right, the last thing we had to do there was do it from an equation. I'm going to copy the equation down at the bottom. So I have some room. So 2x minus 4y equals 12. So if I wanted the x-intercept, that meant y was 0. So I solved the equation 2x equals 12. So x equals 6. So 6, 0 would be my x-intercept. Can't talk tonight. Y-intercept means x is 0. So negative 4y equals 12. So y equals negative 3, which means the y-intercept would be the point 0, negative 3. We then looked at graphing. So when we're graphing and it's one variable, we can use the mnemonic device HOI VUX. That means horizontal lines have 0 slope and our y equals a number. Vertical lines have undefined slope and our x equals a number. When we have two variables, we're going to begin with B and move with M. Begin with B, move with M. Alright, so in this first one, I have x equals 1. It's one variable, and it's x, so that means it's VUX. It's going to be a vertical line through the x-axis at 1. If I look at my next equation, y equals negative 2, that's a HOI equation because it's y equals a number. So it's going to be a horizontal line. So on the y-axis, go to negative 2 and draw a horizontal line. I was just being lazy and putting those both on the same graph. Alright, next one, we're going to begin with B, which is 1, and move with M, which is negative 2/3. So down 2 and right 3. Or up 2 and left 3. Sometimes I also have inequalities. So this next one, because I only have one variable, it's a VUX equation, so go on the x-axis to negative 5. Then it does not have an equal to, so that means it's a dotted line. And it's less than, and since that's a VUX, that means we're going to shade to the left. And we'll do some more graphing in a minute. Then we looked at writing equations of lines given certain information. So when I have a graph, my goal is to find my y-intercept and my slope. So my y-intercept, or my b here, is going to be 4. And then I want to find my slope, find another point it goes through, down to right 3. So y equals mx plus b. So y equals negative 2/3 x plus 4. Then we stepped it up a notch and I gave you certain types of information. And the handy thing to know here is y equals m x minus h plus k, where m is my slope and hk is a point that I give you. So in this first one, y equals m is 2. X, the minus in the formula means opposite, so the opposite of negative 1 would be positive 1. And then we keep k plus 4, and we can just leave it like that. We don't need to do anything else. This next one, though, has a special slope, undefined. So undefined is one of my special slopes, so I'm thinking it's either HOI or VUX. Since it's undefined, that means we're dealing with a VUX equation. So it's going to be x equals the x value they give me, which is negative 4. When you see 0 or undefined as your slope, you don't have to do any calculations. It's going to be either HOI or VUX and using the numbers that they gave you. Alright. Then we might be given 2 points. So my first step is that I need to find my slope. You can do that any way you want. I'm going to do it from putting it in the table. But if you want to do y2 minus y1 over x2 minus x1, that's perfectly fine. And later, when numbers get kind of ugly, then that is probably helpful. So negative 4 to negative 6 is minus 2. 5 to 9 is plus 4. Slope is change in y, which is 4, over change in x, which is negative 2. And that reduces to negative 2. Now I choose a point. I'll choose the first one. And I plug it in. Y equals m. x minus h plus k. So y equals -2, my slope. X minus means opposite, so plus 4 plus 5. I'm going to do the same thing for the next one. 2, 8, 2, 5. At this point, you might notice something, but if you still haven't noticed it, then we'll just do our normal. Up 0, up 3. But something weird happens when I try to do my slope. I get 3 over 0, which is undefined. So once again, it's either Hoy or Vux. It's Vux. Vertical lines have undefined slope, and our x equals a number. Well, what are both my x values? 2. I could have also stopped here when I look in the table and see that my x values are 2. Then we started looking at systems of equations, and we started with systems of equations by graphing. So I graph like we reviewed on the last slide, and we see where they cross. So begin with -4, move with m, so up 3, right 1, and especially if I'm trying to solve by graphing, I like to just kind of do that until I go off the paper, because hopefully one of those points I just wrote is going to be where they intersect. Then begin with 3, move down 1, right 2, and maybe you see already where these are crossing. So my solution is a point, and it's the point 2, 2. But sometimes something weird happens. So begin at 2, down 2, right 1, la-di-da. Begin at -2, down 2, right 1. What kind of lines are these making? These are making parallel lines, which means my solution is none, no solution. So those I had to give a point. When I'm doing a system of inequalities, we're just going to graph, and that will give us our answer. So this first one, x is less than or equal to -3. It's one variable. It's an x, so it's Vux. It's going to be a vertical line through the x-axis at -3. Since it has the equal to, see the line, graph the line. And then less than for a Vux equation means we're going to the left. But every other time that it doesn't look like this very first thing, we're going to think up and down. Okay, so now I look at my next one. Begin at 2, up 5, right 3. Now I can't fit up 5, right 3 on this one, so I'm going to go down 5 and left 3. It is not, doesn't have the equal to, so I'm going to draw a dotted line. And then it's less than, so that means I'm going to shade below. And hopefully you see the little teensy tiny bit right here where those are overlapping, and that's my solution. Okay, so looking at the next one, my first inequality is not solved for y, so my first step is to subtract that 4x over so that it's by itself. So begin at 2, then down 4, right 1. It is a less than, so we're just going to do a gorgeous dotted line. Since it's less than, that means we shade to the left. Alright, now we have y is greater than -2. Since it's a one variable equation, it's Hoy or Vux. Since it's y, it's Hoy, which means it's a horizontal line through the y-axis at -2. Once again, I don't have the equal to, so it's a dotted line. And it's greater than, so that means I'm going to shade above. And my answer is where I have both that blue and the red, which is this section here. In this last system of inequalities, I've given you ones that aren't solved for y. So my first step is to solve for y. So in the first one, I'd have 2y is greater than or equal to -3x minus 2. So y is greater than or equal to -3x, 3 over 2x minus 1. And then I have for the next one, y is going to be less than -1/2 x plus 1. So begin at -1, down 3, right 2, solid line. Okay. Then begin at positive 1, down 1, right 2. Another solid line. Oops, I forgot to shade. So going back to that first one, I needed to do greater than the first one I drew, which is here. And then I need less than the other one. And I want where they're crossing, which is this section. And neither of these had an inequality where I needed to reverse the inequality, but just pay attention that if that was a minus right there, I would be flipping my inequality. So you just want to be really careful with that. All right. After all that graphing, we looked at different ways of solving systems, one of which was substitution. Substitution is happy when one variable is already isolated. It's really not a point to do substitution if a variable isn't isolated. I mean, you can force anything to be substitution, but sometimes you're going to cry. So I am going to substitute in for y in my second equation. So negative 6x plus 4 times, substitute in your equation, 3x plus 4 equals 4. And then do your thing, distribute, combine like terms, yada yada. So plus 12x plus 16 equals 4. So 6x equals negative 12. X equals negative 2. And then we'll substitute that back in. So y equals 3 times negative 2 plus 4. So negative 6 plus 4, which would also give me negative 2 for the y. Sometimes the sides are already the same. So if the left sides of the equations are the same, that means the right sides of the equations have to be the same, aka equal. All right, so then y equals negative 10. And I'm going to substitute back into one of the equations and probably get a... Oops, I just saw that that is a negative 3y. I have a giant smudge on my iPad. Helpful. Okay, so then that would give me, that's negative 3y, be negative 5y equals negative 10, so y equals 2. Dun, da, 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 which means I'm going to have a lot less of a horribly big number. It's not letting me erase because that was too long ago. That's great. So y is 2. Plug 2 in, so negative 3 times 2 plus 1. So negative 6 plus 1, which would be negative 5. After that, we looked at elimination. Elimination is nice when the variables are lined up together and or it would be painful to do substitution. So what we need is for one of the coefficients for x or y to be the same. So in this first one, they're really close. I just need to switch the signs of one equation, which gives me negative 5x, y's cancel, equal negative 20. So x equals 4. And now I choose an equation to substitute in that 4 and solve for y. I always choose one, if I've written on it, I choose the one I didn't write on. So negative 3 times 4 plus y equals negative 12. So negative 12 plus y equals negative 12, which means y equals 0. On the next one, I'm going to choose to multiply the first equation by 2. I'm going to write that below. So negative 4x plus 8y equals 8. And when I combine those two, I get 5y equals negative 10. Y equals negative 2. And substitute it in, I'm going to use the second equation. So 4x minus 3 times negative 2 equals negative 18. So 4x plus 6 equals negative 18. 4x equals negative 24. and x equals -6. So -6, -2. The last one doesn't really have a way around multiplying both equations, so I'm just going to multiply by 4 on the top and 3 on the bottom. So I get -12x minus 12y equals -48, and then 12x plus 6y equals 12. My x's are already going to cancel, so when I combine I get -6y equals -36, so y equals 6. Plug it in, so I'm going to use the second equation. 4x plus 2 times y is 6 equals 4. So 4x plus 12 equals 4. 4x equals -8. So x equals -2. Then what we did was kind of combine both of those and solve systems that had 3 variables. So what we wanted to do there is find the variable that has the same coefficients in all the equations. So for this problem we have z is going to be the culprit. And then what we want to do is split it up into 2 systems. So how we chose that is we put the one that was the only of its sign, so in this case the only positive 9z, went in both sets of equations. So -4x plus 3y, excuse me, allergy season, 9z equals -3. That one went with both of them. Can you get there if you don't do it this way? Of course, it's just longer. But does anybody really care? Nope. So, anyway, you do you. Then we have -10x minus 2y minus 9z equals 8. The main thing with these is you have to watch your signs really well here, because if you miss one negative, then you'll definitely have tears later. You don't need tears. Okay, so this one gives me, once I combine, -14x plus y equals 5. Then 3x minus y equals -5. And now we bring those two things together. -14x plus y equals 5. 3x minus y equals -5. So -11x equals 0. So x equals 0. And my 3 coordinate point. Now I'm going to plug that back into one of these equations. So I'm going to use this one. So -14 times 0 plus y equals 5. So that's going to cancel and give me that y is 5. And now I use both of those back in one of my originals. So I'll just use the first one. So -10 times 0 minus 2 times 5 minus 9z equals 8. So times 0 is going to go away. -10 minus 9z equals 8. So we're going to add 10 to both sides, so -9z equals 18, and z equals -2.